Maybe. Just thinking about recording. Just considering it.
The sign is there for me, so
There we
maybe
go.
that's a yes.
Okay, it just turned on for me. Okay, so welcome to the January Tempo community call, and thanks for joining. This is fairly informal, so we have some things we want to talk about. I'll post the agenda in the chat over here. This is fairly informal, but so you're welcome to ask any questions you want. We'll talk about some of the things we have on the agenda. Feel free to add your own, as well as if you just have a question, you're welcome to either put it in chat or just kind of unmute and ask. This isn't like some canned presentation where, if we're kind of on, we won't want to be interrupted. So yeah, make this conversation if you're interested and ask questions kind of about where tempo is and where we want to go. So did Ananya join? And no, he didn't. Okay. I wanted Ananya to do this first and for first bullet point here. But it's real late for him. I think it's like 11 o'clock where he is or something like that, PM. So I think it's in a couple days. Oh, I think we have a presentation. Mario, did you put that together? Yeah. Why don't you bring that up, man? So we could show the actual slides. We did slides this time. I'm kind of impressed with us.
Yeah, I have a couple. Can you see them correctly?
Yeah.
Cool. So, yeah.
So what is it? There should be a date. Oh, there you go. January 17th. So 4 days from now is the 2-year anniversary of the first commit to Tempo. It's kind of been an on and off project. We deved on it for 2 or 3 months, me and Ananya, which is why we really wanted him here for this. But so it was just me and him at first. And then we had about 3 or 4 months off where we were working on other projects, and we kind of came back that fall. So maybe like slightly less than 2 years of work and 2 years since the first commit. And it's been a fun time. For 6 months, it was like a heads down, nobody knew about project, and we had a lot of fun building it. And then we kind of announced it, and we've had a fun community and a lot of people who are enjoying using it. And yeah, it's just been a lot of fun. And the team is huge now. Conrad, Marty, and Mario are here, and then we have some others who couldn't make it, I suppose. But a lot of great devs putting some time into this project, and it's just fun to see something, grow that much, I suppose, and get traction like that. So yeah, and the commit message is silly, but the very first commit to Tempo was Loki, like with 90% of the code deleted, and then I started from basically that shell, which kind of defined the major pieces, and started like putting code into that. So I carved up Loki. That is the first commit. So yeah, thank you all for being involved in the project. It's been fun. Cool. What else we got today?
Right. Yeah, we have the upcoming next release, which is 1.3. I think it's been roughly like 2 months, like early November, since we released 1.2. And then we did a patch release 1.21. And yeah, we just want to comment a bit on what are the main changes. And yeah, so I guess the highlight of the piece is full backend search. We will talk about this more in depth a bit later, but essentially, we started with search in the past release, and we were searching the recent traces, but not the full space. So we were able to search for traces in the ingesters, but once blocks were flushed to the storage, yeah, search wouldn't be able to search for those. But now Tempo is able to. So yeah, this is great. And not only that, there are obviously the space is way bigger when you're comparing the full rotation with compared to only recent data. So to support full backend search, we're also making available the usage of cloud functions to kind of be able to parallelize more and have more compute power to search across more blocks at the same time. So yeah, pretty exciting. Then we have other features and improvements, such as support for inline environments. This is a deployment theme in Tanka where you can define environments and have them evaluate on runtime instead of defining them statically. Yeah, which depending on your deployment infra, or yeah, depending on your deployment, can be very useful. Regarding search, we dropped the tag cache, so tags are extracted on demand. This has the huge benefit of not being limited by the size of a cache, so we can return thousands of values every time. We also were hit with huge traces, and so we improve the memory efficient on compaction and block cutting. So yeah, to overcome those. Now we're also exposing limits as metrics. We also have, I think this is this was a very common issue in the community, having unhealthy compactors. We fixed that. And yeah, not to go for like 20 minutes listing every improvement. There are obviously many more. I don't know if anyone wants to comment one that I missed and which you have probably mentioned.
I haven't looked at the changelog yet. We've cut the release candidate, right?
Yeah, that's exactly the next one. Yeah, and we have the release candidate. It's available on GitHub, and all the builds are also available in Docker Hub. So yeah, if in a week or so, like approximately, everything goes well, I think around that time we will be cutting the proper release 1.3.
There are a couple breaking changes in there, maybe that we could mention real quick. The OTel gRPC port default changed. So if you're manually configuring that, then it should be okay. But it did change from 55.680 to 43.17. So that came in because of the dependency update. And then we did also remove a deprecated gRPC endpoint between the distributors and the ingesters. And if you're running 1.0 or later, you should be fine. But if you're upgrading from a beta, then there's something to note there. Cool.
Cool. I was looking for the tag. I was looking for the tag in Docker Hub so we could post it here. Here it is right here. Okay. Maybe. I think this is it. Docker Hub just being really slow for me, maybe. But I'm pretty sure that's 130 RCO. So like Mario said, maybe like in a week or so, we'll cut the real one if we don't see any stability issues in our internal environment. Cool. And then the cadence has been what, every 2 months or so? For me, I like that. I don't know if people have been okay with that kind of a release schedule. I feel like that's we get about a good amount of features and bug fixes and improvements in about that time. So we're just kind of playing it by ear right now. We don't have anything formal, or we don't have anything required, like we release once a month or anything like that. And I feel like things are working out pretty well. If that's not working out for you, feel free to let us know either through this meeting or Slack or whatever's easiest for you. Cool. What's next?
Yeah. I'll talk a bit about the metrics generator. So this is a project we're working on right now. So this will be something for the next release. So we're looking at a different direction now. I'll just share my screen for a second because I'm not using the slides. If I can find the right option here. Yeah, should be able to see this, right? Okay. Is this readable? Just, let me know if this is too small or whatever.
A little small, but not terrible. I see you have 6 hearts. It's a good number of hearts. Maybe I should go add one.
Yeah, sure. Yeah, I'll do it like this. So yeah, the metrics generator, this is a new thing we want to add to Tempo. The goal of the metrics generator is to generate metrics from the trace data as it is being ingested. So this is a completely new feature in Tempo. So far, Tempo is, a tracing data store. You can store traces, you can fetch traces, and you can also search for traces now. With the metrics generator, we also want to generate metrics and push them somewhere into a metrics data store. Since this is, a big new component, there are a lot of new design decisions. We've been making this design document, a design proposal, and we also wanted to make it public so that, people in the community, basically everyone, can see what we're working on and can also comment and suggest stuff. So this document describes how we are planning to build this component, how we will add it to Tempo. You can, read the document, leave suggestions, leave comments, provide feedback, whatever, and we can take this into account as we build the feature and just, make it better for everyone. This is also because, we run Tempo on our own way in our internal environment, so we use it in a specific way. So when we build stuff, we build it for ourselves, kind of, but we want to make sure that other people running Tempo also will be able to use this properly and, can have a say in how things work. So that said, I made a PR with the document. So this is just a PR with a markdown document. This PR will remain open for like a couple of weeks, so you can check it out at your own time. And you can leave a comment here in the thread, or you can leave a pull request review. Just, do whatever works for you. You can also leave a Slack message or DM me or I don't know, whatever. But yeah, I was just planning to quickly go through the document just to give like an overview of how it will work. So this describes a bit what it's about. So regarding the architecture, we were thinking about adding a new component to Tempo. So a new microservice, which is specifically responsible for generating these metrics and pushing them to Prometheus or a Prometheus compatible data store. So that means that the ingest path will change a little bit. So thus far we had a distributor, the ingester, and then the backend, which would process the ingress. With this change, we will be adding a new component, the metrics generator, which will also receive data from the distributor. So that means the distributor will do 2 writes for every write request, one to the ingester and one to the metrics generator. The reason we will be adding a new component is, we're kind of considering different alternatives. An option is, for instance, to integrate this into the ingester, to just run it together with the ingester. But the concern was there that would make the ingester very complicated. It would have to deal with traces, with the state of these traces, flushing the traces. And it also has to think about the metrics and pushing them. It's kind of, we were worried it would be too complicated. And by adding a new component, it can hopefully remain simple. And, if it blows up, only this part of Tempo will blow up. So it's kind of like a limited blast radius. But it's like, a bit more description here. Good to know here is we would be using the same ring mechanism. So the same mechanism writing to the ingesters that would be used writing to the metrics generator. There's a bit more detail here. We would use a gRPC protocol. And this is kind of how the metric generator will look inside. So this is a component that also exposes a gRPC server, like all Tempo components. So it will receive a batch of spans from the distributor, and then it will pass these on to different metrics processors, which will process the spans and then generate metrics. It will update counters and stuff like that to be able to write the metrics. So for every tenant, we will have like a separate copy of the different processors. So that way, all the processors are isolated per tenant. And then we have a different process, the metrics collector, it's just the name, which will regularly collect metrics from the different processors and then push them out into Prometheus or Prometheus compatible backend, for instance, Cortex, which means Cortex is multi-tenant. So that way you can have multiple Tempo tenants writing to multiple Cortex tenants. And again, there's a bit more detail here about the different components, some of the trade-offs. And initially, we were targeting two processors, the service graph processor. This is a processor that already exists in the Grafana agent, and it can generate metrics, which can power a service graph in Grafana. So I put the link to the docs here. They look kind of like this. This can make a service map of all your services based upon trace data. So we'll be able to generate these metrics using Tempo. And the second one we want to integrate is the span metrics processor. This processor just ingest all the spans, and for every span, it will keep track of request, error, and duration metrics, and just send them to Prometheus or whatever. And this will allow you to basically see these red metrics from all the spans in your data. Again, there's a bit more details here. There's a bit more detail here, so feel free to take your time to read through this. I think that's kind of like all I wanted to say about this. So yeah, we're targeting this for the next release, Tempo 1.4. I guess that will be in 2 or 3 months or something like that. And this will be an initial implementation. So, there are a lot of concerns about how do we deal with crashes, with data loss, with persistence, like a wall, stuff like that. Those things will probably be postponed a bit until we have an initial implementation that has the full pipeline. And then at a later stage, we can look at how can we reduce data loss and make it more reliable.
Cool.
Yeah,
I think maybe I think that's a great design doc, and it's our first one as well, and a good start there. I think the questions for me, for the community, like for people who want to participate in that, are things like, what kind of metrics are people interested in? If there's things that are not on that list that people might see value in, we'd love to hear from that. And then, of course, if there's any, just any kind of just concerns or thoughts about the design, or if it would work or not work, There's also, we're supporting the Prometheus remote write endpoint at first because it's so, widely used, and we have a lot of experience with it. And there's a very, there's a very easy to use Go client, but we also kind of expect longer term to consider other formats, OTLP kind of being the kind of the obvious other one to eventually support OTel metrics. But Prometheus remote write, I think every major vendor supports it. Every metrics backend supports it. So I don't think you'll have any issues, using it with a time series database. Cool. Ananya's here. Ananya, do you want to announce the 2-year anniversary of Tempo?
Hey everyone. You mean again?
No, it's not happened. It's sweet.
Whoa, that's awesome.
Sorry.
So, yeah, January 17th is the official 2-year anniversary of Tempo. And we're counting days from the very first commit that Joe pushed to Tempo. And yeah, it's been super exciting. I think like I've been in the team from the very beginning. And it's been super fun. It was like closed source development for a while. We announced with O2O in October 2020. And yeah, it's been super fun. We've onboarded new team members, grown the community. Yeah, it's been fun. Congrats, everyone, and congrats, Joe.
Thanks. Congrats on Anya. And we did announce it earlier. I apologize, but we'll do it twice for you, bud.
No, you tricked me.
Also, I didn't even realize it was coming up. It was Nanya who remembered, so he slacked me on Monday, I think, of this week, and was like, "Hey, did you remember that the anniversary is coming up?" So, appreciate the reminder. I would have let it go by and not remembered. Cool. If I had a beer or it wasn't, noon and where I am, I would drink to the project, I guess.
So
Cool. What's next? I think I'm next, actually. Full backend search. So I think I have one slide. I also kind of wanted to do some screen shares. Yeah, this slide's awful. Excuse me. I have we were like all in this presentation like 2 minutes before before the community kill started, like rapidly slamming bullet points in. So this is not a great slide, but I'll get to the content. It'll all be there, and I'll share some stuff as well on my screen. But anyways, so we're building this backend search functionality, and we're kind of building it on top of a format that was really intended to be a trace by ID search. So what we did initially was we took a bunch of OpenTelemetry Proto and we batched that up into a trace and we pushed it to S3. So our backend is organized around a trace, like blob, a trace every, or blocks of traces. It actually makes it kind of hard to search. It's not really built for search. It's built for trace by ID. So our first attempts, the team is kind of split into two factions at the moment. I'm currently building out ways to just parallelize the search path and use cloud functions and use some of these features, while other members of the team are looking at, well, how do we improve this backend format to be just easier to search? So we're kind of doing both of these things at the same time. And right now, 1.3 provides the ability to do full backend search either in cloud functions, or you can also do this in the queries themselves. So they both are capable. Right now we are consuming about 180 megasecond, and for our scale, we would need hundreds, maybe even 1,000 plus queryers to search the backend in any kind of reasonable time frame, which is a lot. So we looked at cloud functions. It's a great way to kind of have burst, compute on demand, and pay a much smaller price than kind of always having allocated space in a Kubernetes cluster or in some kind of other provisioned environment. So I think for different people, the queries are extremely easy to set up. In fact, the queries require no setup. If you just use the queries, they'll work. And so people who are maybe receiving a low amount of traffic will be able to use backend search immediately just by scaling their queries up. But if you do have a considerable amount of traffic, you're going to need probably some help for that. And that's kind of what the cloud functions part is for. So with 1.3, there'll be a blog post as well as some help on sharing how we have set up some Terraform, some other details. I'll go through all of this stuff. So if you want to attempt this, if you want to try to use the cloud functions for backend search, you will be able to make use of it as well. Currently, we're doing about 10 gigs a second, which isn't great, isn't terrible. It just costs so much to pull Proto, unmarshal it, like go through every span looking for some kind of condition, return true or false based on that. The Proto in particular, marshaling is just very expensive in CPU and memory and just takes so long. And that's kind of what the backend team is, or the team that's looking at the backend format is really focused on, is like, how do we get rid of Proto? How do we make this more efficient to marshal? How do we make this more efficient to search is really kind of the direction they're looking. And so 10 gigs a second isn't great, but it's not awful. And then 5 to 10 cents per query. So we can kind of interestingly, like really quantify how much a query costs, because we're paying for these Google Cloud Function resources, where you can see I'm spinning up thousands of functions for, I'm doing a query, I'm spinning up thousands of functions to answer that query. And I'm estimating it to like 5 to 10 cents per query, which isn't, again, great, isn't terrible. It's good enough for now. And we're just going to move forward and continue to improve this feature, in the future. In fact, I have a PR that won't go in 1.3 because it's just too much change, but we'll do a PR shortly after 1.3 that will, I think, improve this quite a bit, make it a little bit easier to search before the full backend kind of shift. Let me do a little screen sharing. And let's see, doink. Hopefully.
Sure, I was just gonna say,
Yeah.
you said 10 gigs a second is not impressive, but at our volume, it queries an hour of data in just a couple of seconds. That's pretty impressive.
Yeah. I mean, it kind of depends on what your conditions are. An exhaustive search isn't a couple of seconds, but if you do search for something that's relatively common, like maybe it's just a time range, maybe a service, it'll find it. Yeah, and it'll return in a couple seconds if you're
Lucky enough.
Right. I apologize for showing you a Stackdriver dashboard, but I don't have all these metrics set up in Grafana and Prometheus just yet. But you can kind of see some of the stats. I was just doing some searches before this call started to get some metrics in here. You can see like kind of latency per function, the number of instances, like we're breaking 2,000 instances when we are doing some of these queries. And then you can see the requests per second are like 100 or so. I really kind of want to push this even harder and get it to the point where it can exhaustively search an hour or so in seconds. I think we can. The kinds of things we're fighting are like cold start, which is a common issue with functions, as well as just kind of like the fan out, like how many processes are putting pressure against cloud functions to make it start scaling up hard. And so there's a lot of different concerns, and it's kind of a fun world to work in. I've not worked with Lambda or any of these cloud function platforms before, so I'm learning a lot myself. And like I said, there'll be a blog post. I'll talk about a lot of the things that we challenges we had and how we have set this up and how it works for us, so people can kind of mimic that and use similar setups and get kind of a jump start on some of this. So this is the search interface, and this hasn't changed. I wanted to show this to make that clear. The search interface is the same as it was before. Previously, though, up here in the corner, it says like last 1 hour, right? Previously up here, this was not respected. It just searched whatever happened to be in ingesters. So you could say, show me stuff from 2 days ago, and it would show you what was ever in ingesters. So now the change here is basically Tempo is using the range provided. It is going to the backend or the ingesters, making a choice and searching for the traces that you queried based on these conditions. So this is all the same. We just kind of added the ability to respect this. And I'd say we're hoping to get this in Grafana Cloud as kind of still as a beta, but in Grafana Cloud for people who are using that, maybe in the next month or so is the goal to roll this out to everybody in Grafana Cloud. And we'll, Grafana Cloud volume is significantly lower than ours. So I think we have a lot of questions up in the air there in terms of like, do we use cloud functions there or do we continue using the queries? And so there's just some operational questions about how to do that correctly that are still on the table. But I'd say in about a month, we would hope for this to be available in cloud. And then finally, here's a trace. So this is a search. It took about 13 seconds. Again, we're searching like around 180 megasecond is our ingest. And at our scale, search feels a little like a batch job. It's not quite as responsive as if you're sitting at Prometheus or you're sitting at Loki and you're executing these queries, right? And this is kind of what we really want to ratchet down. We want to get it to the point where you type out a query like you do against Prometheus. Within under a second, you get some nice metric back. You can kind of repeat. You can kind of get in a good feedback loop. Filter down what you're looking for, and finally get the trace that you want. So it's not quite there for our scale, but we think we can easily hit that in cloud, which shows most users of cloud have significantly less than we do in our operations cluster. And you can see here, I did expand this one section. So this query, which was a 15-minute query, it found 4 blocks in our backend that matched, and it made 7,000 jobs to search those blocks. So this is kind of the challenge, is we have all this data. It made 7,000 smaller jobs. Each is roughly about 10 megabytes, and that's configurable. So each of these 7,000 jobs says, go look at these 10 megabytes. And then all of then all the serverless functions, they'll spin up. They get these jobs. They're like, I'm going to search this 10 megs. They pile through it, they return their answers, and we, are looking for the results, hopefully in a reasonable amount of time. But yeah, So search is on the way. It's in 1.3. You can start experimenting with it now. There is a specific Grafana version that's needed to pass the right parameters. And I guess I don't know that off the top of my head. We have it in our operations cluster, but I will provide information about that in the blog post, like the Grafana tag to use, how to get all this set up. It'll be a complete like overview of how to do this. So people can start experimenting with us or experimenting with it and give us some good feedback. So this start and end parameter, maybe you can see that there. Yeah, this is the new parameters passed by Grafana, the latest versions of Grafana, and this tells Tempo to use a range query instead of just do the ingester query, the recent trace search we had been working on previously. Cool. So yeah,
cool.
adventures in Cloud Functions, I guess.
That was fun.
Thanks. Yeah, it's been interesting to work on. It's been a mix of operations and code, and I used to do operation work on AWS, and so I have a lot of experience there. And at Grafana, we use Google Cloud, and so I don't have as much experience in Google Cloud, and so I feel like the dumb developer who is always knocking on the door of the SRE, like, what's going on with all this? How do I fix this? Where's the billing page? Where's the everything? Basically, I'm kind of like isolated from that, or not isolated, but I am ignorant of a lot of it because I've not dealt with it a whole bunch like I did in my previous job. Yeah, so full backend search is on the way. It's in 1.3, and we'll just continue to improve and continue to communicate how we're doing those improvements. And I think for most scales, it'll work great. And then for the larger scales is where you're going to need to bring in the cloud functions and maybe do something a little bit more operationally complex. Cool.
Also, this cloud function support is on GCP and not on the other cloud providers yet.
Yeah, that's a good point. So we use Google Cloud, so I kind of prioritized it. Actually, we have clusters on every major cloud, don't we? Or at least the Azure, Google, and AWS. So that's kind of next steps for me, is just add support for those other providers. And this is something that I don't know how to do, but I really want to find a way to make, like some kind of cloud agnostic code package that I can deliver to all three. And my initial kind of like searching was not promising in that world. So I'm not sure where that's going to go, but we'll figure it out. Cool. Sure, you're welcome to ask a question.
Yeah. So with the new backend search, the in ingester search will be totally gone. So we can't use that for So it's only full backend search.
It's actually both. So with the latest version of Grafana, it'll pass that start and end parameter, and the query front end will create those jobs. So we created those 7,000 jobs. Some of those jobs will be ingester search if your range hits the ingesters, basically. So all of the stuff that you previously used is still there. The recent trace search works. It's just been extended to also look in the backend if it needs to.
Cool.
Mm-hmm. All right. I think Marty's got some information. So Marty's kind of heading up this team that's really looking at the backend formats. He's going to chat some about that.
Yeah.
Do you want me to share the screen?
No, yeah, sure. That's fine. Yeah. I always have trouble getting it to be full screen, so it always looks really bad. Yeah, cool. Yeah, so we kind of touched on this before a little bit, where the current backend and block format for Tempo is compressed OTLP protobuf bytes. And so we kind of are feeling like that's the bottleneck for some of the things we want to do, search being one of them, but there's a lot of other stuff down the line, like time series queries and metrics and things like that. So we've been looking at what can we do in there? So something like a new block format or even a new trace format. And so I'm just going to talk about kind of like the current status of what we're doing and what we have done. And we'll have some cool numbers and stuff. Cool. Yeah. So we probably mentioned this on previous ones. But one thing that we dug kind of deep into was the current search in the ingesters uses flat buffers. So it's, and we had a good experience with it. It's quick, flexible, like it worked well. So we were looking at it to do as the entire trace in flat buffers. So what we did with this approach is a 100% OTLP round trippable format. So it's not like the perfect, format maybe for things that we want to do, but it's something that's basic and easy to do, like a very good first approach. And it's useful. The round trippable is important because if we want this to be the full block format, we need to be able to actually return that. That's Tempo's response format. So some of the optimizations in flat buffers I guess you have to do them maybe, or it's important to do. Some things you get are string and object deduping. So in flat buffers, I guess I should explain what flat buffers is. Flat buffers is just, it's a format where the on-disk and the in-memory layout are the same. So once you have the IO, the result of the IO, you can just load it straight into memory and there's no deserialization step. So you have a kind of a pointer to a bunch of structs and you can just start iterating them. So some things you can do are deduping. So in protobuf, this doesn't really exist because when you deserialize, every string will be its own copy. In compression, that's gone away, so it doesn't really make a difference. But in flat buffers, we actually can reuse those objects. And then other things like reduced nesting and flattening. So if you're familiar with OTLP, the resource spans and resource, kind of like the indirection of the two different structs, that's things that we can optimize here. And then vtable trimming. This is something where flat buffers has vtables, and if you have a field unset, it actually can trim that from the result. So if we can kind of reorder some of the fields and put less frequently used ones at the end, then they can be eliminated from the payload. So going through some numbers, what we did is we took one of our blocks out of our internal environment, and it had 154,000 traces in it, and it was compressed with LZ for 1 megabyte dictionary size. So all things being equal, it's the exact same block, the exact same data, but the only difference is the trace format. And so I can just kind of walk through some of these numbers here, but I'll summarize it saying that it definitely looks promising. It's a faster for sure, but the final block size definitely has increased quite a bit. So it's not a clear win. So this was a good experiment, but it didn't necessarily have like a clear thing that we necessarily want to merge or go down. So, but we'll kind of maybe just put this on the side and keep considering. But yeah, so search latency, just searching that block and an exhaustive search of every span and tag. 21 seconds for protobuf, 3.3 for flat buffer. So that's about a 6.6x increase. And the rest of the numbers down below are kind of similar: traces per second, spans, attributes. So the final kind of like speed up was maybe about 6.6x, right? The actual data processing speed is that last one. It's actually, once you have the IO, it's able to go 12 times, almost 11.5 or 12 times faster. But because the compressed block size is 1.76, you're losing some of that benefit.
Sorry, I had a quick question. When you were doing some of these tests, like what kind of search were you doing? Were you looking for specific attributes or?
No, this is exhaustive. So this is, so this is searching for a non-existent attribute. Actually, it was a benchmark that was written just to evaluate every string. Yeah.
Okay. So it just, piles through everything and looks for something that doesn't exist, basically.
Yeah.
Purposefully to, Okay, that's cool.
Yeah. There's this link down at the bottom. So if you're interested, this is on a branch I have, and that file there is the schema. So it's a flat buffer schema for this new stuff. So that would probably be a good place to start if you're interested in looking at it. So yeah, that was kind of our findings from that. Want to go to the next slide? So what's next? So like I said, that wasn't really conclusive. So we're going to keep working on this. So next up, we want to look at something very different. So columnar, doing the whole block as a columnar store seems very promising. There's a lot of things we could do there. There's other formats, but Parquet I think is a good contender that we'll look at. And columnar makes sense because what if you could extract all the searchable tags into their own columns? That would be really great for search, but it also brings a bunch of other work. So just the additional complexity of recreating the trace from those different columns, the different schema that could be per trace per block, things like that. But yeah, so I think that's a really promising thing that we're going to look at. And then flat buffers, the main concern really or the main drawback was the block size. And so if we could reorganize the page to be as like an entire object, like it would increased amount of deduping that we could do a lot, and it would bring that block size down. I mean, and I think that could be really competitive. And then if we're redoing the whole page, then maybe we could do a more searchable structure. Whereas right now it's each trace is an individual set of bytes. So doing it at the page level lets you kind of like break open that structure. Cool.
Cool.
Yeah, that's it. Cool.
Exciting stuff.
Yeah. Nanya, is there anything you want to add here?
Nanya did a lot of the work on Columnar. That's right. A lot of the what was it for the hackathon? He spent some time on that.
Yeah, we had a company internal hackathon. I was just trying to see if the SDKs on the internet have everything that we need to work with Columnar. So do they have good support for compression, paged access, pulling only the columns we need? I think that's obvious, but and I think the results of that are inconclusive as well. There's one popular library on the internet, and Apache is also porting some of their code into Go, and so there's some confusion there, and so I think we're gonna have to look at that as well.
Cool.
Yeah.
Something interesting might be like a hybrid format. So we swapped to LZ4 from Z standard because of the speed of decompressing, but we lost some space on that. So we could gain that space back, go back to Z standard and keep the existing block format and just write a columnar format to the side maybe and use that for search. I don't know. There's a lot of options here.
Yeah.
And I think the team's kind of got their hands full in figuring out, what direction to go.
Yeah, that's definitely one option. We're thinking about either an index on the side or moving the entire trace to columnar. There's some movement. Yeah, maybe it's interesting to mention this, but there's some movement on this in OpenTelemetry as well. There's a PR or two. I think we can link that in the community doc. That's beginning to look at columnar formats for the trace data. So yeah, maybe we'll drop some links.
Yeah, we should have made Juracy come to talk about it.
Yeah,
guest speaker. Cool. Does anybody have questions? I guess we've got about 13 minutes left in the official time here. I'll stay on a bit longer if people do have things they want to chat about. I'm fine with that. But if anybody has questions, you're welcome to unmute and ask. You are welcome to put in the chat or however you'd like to ask.
I had a question, perhaps. I know Tanner had chatted with Marty regarding our compaction settings. So before the break, basically the holiday break, we kind of dropped our compaction window from 5 minutes to 3 minutes, and that kind of gave us a boost in compaction. But for like a very short time, I feel like for like maybe 24 hours, we compacted way more, and then it kind of went back to the same level as before. So right now we're at 3 minutes. And we're kind of having trouble kind of keeping the block list under control. Like the block list is kind of growing, and we're not even throwing more volume at it yet. But that's kind of like the next thing we want to do. So we're kind of wondering. We feel like there's a limit to how small we can make the window. Also, like we can probably drop to like 1 minute, and then that's what I imagine is like that's the lowest we can go. And then we're wondering like what's the other things we could try to help with compaction, because compactions we actually are tracking a metric. We're running like 36 compactors, and we're tracking a metric where the number of compactors that have like CPU usage less than half a core, and that is consistently like 10 to 15 compactors are in this state. And so we're trying to see like what we can do to just maybe increase CPU usage across the compactors, and like the hope that they will do more compaction, or there's other settings we can mess around with.
Yeah, so you said the boost only worked for about 24 hours. I guess one thing in mind is I'm wondering if like the actual amount of work that was needed did decrease because the compactors were able to finish a compaction or get through some compactions that were backlogged, whereas before maybe they weren't able to keep up. the block list is out of the block list length is kind of growing. Like, do you have a rough number on that?
Right now, our block list on the busiest cluster hovers like I'm graphing like a month. Let me like do 1 day. It's like hovering between 30 and 31K right now.
Ooh.
Yeah, it's kind of high. Now, is that giving long query times?
That kind of
the main
translates.
issue?
Yeah, it kind of translates to longer query times. Like our query times seem to be hovering more around like 10 seconds now. It used to be more like around 5 seconds when the block list was shorter.
Yeah, I think maybe 18, 19 is about as big as we saw it when we were at our largest cluster sizes. So maybe there's some stuff we could tweak, right? Certainly, so doing your window size down allows more compactors to participate in the early time slots, which will help. But it also makes for more blocks in the long run because you have a shorter time slice. The things I guess I would look at are like how many blocks per time window exist. Maybe you could increase. So there's a setting that is the maximum block size it'll make, as well as like the maximum objects it'll put in a block size. If you bump those up, maybe it's refusing to do some compactions it could attempt because those are too low. I don't know what those are by default or even what we have those set up, but I know that those are some limiters on what the compactors will do.
Did you say you have 30 days of data?
No, 7 days or 8 days.
Oh, 8 days.
Yeah. And it's also like I'm bringing this up just because we're in a state where we want to increase like the volume of traffic we're sending to Tempo. Right now we're like at 10% of our sampled volume, which is like a number that doesn't really mean something out of like in this context. Like there's a lot of ifs and what that number means, but like we're looking to like bring it up to like 20 and 30%. Like our goal is to have everything unsampled basically in Tempo, and it's just like right now we want to make sure that our block list is under control. I think for the rest of the settings, we're running close to the defaults. I think chunk byte size is like 5 megs, I think. And then
yeah, it's a terribly named configuration option.
Yeah.
We adopted that from Cortex, I think. But whatever,
Yeah.
it's just how much it'll pull in a single batch from the backend per S3 request or GCS request.
Yeah, but we're close to the defaults for everything else, or at least the last time I looked, like before the holidays.
Maybe we should exchange some of your config options in Slack, and maybe we could tune a bit there, because that is really long, especially for 8 days, and probably your volume. That is a very large block list. We can get that down.
For 8 days, if you do the math, like the least amount of blocks you could have is whatever the compaction window is spread out over 8 days, and that's only in a couple thousand. So it's off by order of magnitude. So something doesn't sound right. Are you still running your custom compactor?
Yeah, so yeah, we didn't have time to update but now that 1.3 RC is out, like my goal is to update like our test environment to that, and if it's good, then I think that will, yeah. I'm not like excluding the option that like something's different there, and maybe that is a reason, but
sure.
Oh
yes.
No, actually, I meant those improvements that I saw were great. Like Tempo 1.3 won't have all of them, so I'm not sure that it'll be better. But yeah, it's worth a shot.
Yeah.
But yeah, I was going to apologize actually. So maybe in the next release we'll be able to get some of them. We did write them down on an issue somewhere.
Yeah. To be honest, actually, it's just like it was hard to see exactly what was happening before, just because we had like a lot of these like huge traces, 5 million spans and up, and now those are mostly gone, and we're kind of having a better picture of what happens with the cluster, where like when stuff is more normal, or at least we don't get a lot, like a really large amount of these very large traces anymore. But yeah,
that'll break a lot of things. 5 million spans.
It's actually we've seen like 15 million spans also. It's not like short traces. It's just those traces run for like hours and hours and hours. They should be like we're moving our stuff to use links instead, and that fixes the problem. It's just like we haven't done it everywhere yet. So
yeah, now there is a change in 1.3. The ingester will be more strict about allowing writes for those large traces. So previously, as soon as it flushed from memory, it would allow more writes. So it kind of escaped the max trace size limit. So we did tighten that up a little bit. So hopefully that won't actually cause any ingest issues that you don't want, but that would protect against some of these larger traces once they hit the compactor. They just wouldn't be able to be written.
Yeah, actually, all these settings are, we disable them, like max traces per user and max bytes per trace. This is like, we set this to 0 because we don't have a way of knowing, basically, at this moment. But I don't think this long term. I think the goal is to bring this back under control eventually. Also,
I'd love to see your all's metrics. That's awesome.
But actually, I have a kind of a follow up, which is, do you have like recommended CPU and memory allocations for couriers? We're seeing a lot of, now that we have way more people using, we're seeing more courier OOMs. And we want to know what would be like the ideal, what like you guys allocate right now. I think we're on like 2 CPU and 4 gig limit per courier, and
How many
we just
queries
don't know
do you
where
have?
to go, keep going up. You know,
We have nothing. Our queries use about 100 millicores each, 100 to 200. I think we have maybe 2 gigs allocated, and they sit around 1.5, just whatever, because Go holds memory, not because it needs it.
Yeah. Metrics seem to indicate that they mostly don't use that much, but they seem it's spiky sometimes. Perhaps it's our large traces, or I'm not sure. But we have a lot of restarts. I mean, like hundreds per courier because of ohms.
That's really weird. The only thing I can think is people are querying these 15 million span traces, because at a reasonable number of spans, like, I'd say our queries never oom. Like when we have big traces, what we tend to see is the compactors oom, basically, while they try to recombine, which I know you've seen as well.
Yeah,
So
yeah.
that is a surprising thing to oom. I don't know if, I guess I would try to track it down to, what is being queried at the time, and see, maybe hopefully you can track it down to which thing, which trace is being queried. But how many queries do you have as a question?
It's not that much.
Okay.
I have query volume is kind of slow. It's kind of low still. Adoption like is growing, but I'm not saying like we probably don't have multiple queries per minute.
Okay. Yeah, it probably is somebody. Well, my guess would be it's somebody hitting a big query, but you could also consider increasing the shards. So there's a configuration option to say how many shards to take a trace by ID search into. If you make that larger, it'll make the job smaller, because each one will be smaller, and then you could scale out your queries. I think we have 25 small queries basically. So maybe like a lot of small queries with a lot of jobs would be a better match. Then your query front end will oom once all of the jobs hit that, and it tries to recombine a 5 million span trace. Something we've been talking about, which we haven't done, but it sounds like it might help you as well, is start having some of these limitations on the query path, which we don't now. So if on the query path it sees it's about to attempt to return a 500 megabyte trace or something, it just stops and returns an error instead of ooming.
Yeah, I think definitely the one thing that we know is that like people sometimes will just like accidentally try to query a large trace, like they don't know that it's a large trace. And then if we had a way to cleanly return this trace is too large, because I know that's what some vendors do also. And then we could say, well, oh, this is too large, like maybe don't query it, or but
okay,
yeah,
that's a good idea. I'll put that. We have like, we keep what milestones. There's a 1.4 milestone up now. I'll file that as a feature request to enforce limits on query path, basically enforce that max trace size on the query path. Because
I know, because we say we basically disable the limit on the ingestion, we end up with these huge traces that can't be queried, and then like every time that it happens, it's like, oh, something's happening, like no queries are responding anymore, and then like, yeah, somebody did a big query or queried a large trace, and yeah, but we understand like the correct ways, like to actually limit how big they are when they come in, instead of not limiting it and then also causing problems on the query path. But like, yeah, I think having this setting in 2 places would be cool.
Cool.
Thank you. That's all I had.
Cool. All right. Thanks, Gabriel.
Cool.
Anything else, team?
Yes. Sorry to keep this waiting for the very last minute, but I want to do the... Oh, and one more thing. Tom always does this, Tom Wilkie, and I've always wanted to do this, but Anders, who's on this call, wrote a blog post about tempo and Linkerd. And I owe him a huge apology because I worked with him on this and I was supposed to follow up and it went up and I didn't know, and he told me that it actually went up. So this is awesome and sorry about that. But this is definitely cool.
It's totally fine.
We get a fair number of questions on tracing and service meshes, and it's not something I've ever messed with. So having good content here is great. Thanks.
I mean, Anders was chatting on the Tempo channel about Linkerd and Tempo, and I messaged him and said, hey, you should turn this into a blog post. And it happened.
The TLDR, at least for Linkerd, is that they only support the B3 propagation format. So that kind of logs you into what you can do. And yeah, but other than that, it was smooth sailing.
Cool.
Yeah.
Cool.
Is B3 Zipkin?
Yeah.
Yeah, that's so weird because Istio only does Zipkin too.
Yeah.
It's bizarre.
So
Okay.
what I've heard from Linkerd, I think they're waiting for the official spec to stabilize. The hotel open telemetry spec thing. But that might take a while though. So yeah.
Cool.
So yeah, thank you for accepting my blog post. Good stuff.
Thank you. Thanks, Ananya, for putting that together.
Cool.
All right. That's that. I think it was a good one. Appreciate everybody for showing up. Feel free to jump in our Slack and ask questions. Of course, there's the GitHub repo, a million ways to contact us. And Gabriel, like we were talking, if you want to follow up with a configure something, we can help diagnose that issue a little bit and maybe get your block list down from a crazy 30,000. But thanks everyone for showing up and participating. Everyone take care.
Thank you.
Have a good one.
Have a good one.
Take care.